Hi guys, welcome to this presentation. In this video, I'm going to walk you through how to use Keras and TensorFlow to implement stacked LSTM for a problem of text classification using IMDb movie reviews dataset. TensorFlow, so I'm going to use sequential method and also use some of the layers like embedding and LSTM and dense. In this example, I'm not using dropout, but this is again something that you can experiment with. IMDb is your data set. So initially, the first time, it might take a little while, maybe a little over 2 minutes to download the data set. But once you're done, it is going to store the data locally somewhere on your PC, and next time on, it will be pretty quick. So it's like, in a second. So here I'm using the IMDb package of Keras, and load data is a function. It's going to prepare your arrays, xtrain and xtest. Padding using, the post method, and essentially to normalize the length of these samples. And I'm taking the length as 160. I observed the typical length of a sample is around 100. So again, this is a subject to experimentation. You can try different length of sequences. So the variant of LSTM that is being used here is stacked LSTM, where you have series of layers on top of each other, and they are connected through return sequences. That means for each of the time step, the bottom layer will provide the output as input to the higher up layer. And the highermost layer is going to contribute with a consolidated hidden state, and that will be used to classify if the sample is or the review is positive or negative. So this is what we are going to configure. So this is the embedding layer. This embedding layer is going to convert the input, sequence or a number or indices, given by Keras to a dense representation of 100 dimension. So this is again a topic of experimentation. Input dimension is the vocabulary size, and I have taken 20,000 as the vocabulary size. So you need to mention that in the embedding specification. Yeah, so essentially, so the embedding layer, gives the random numbers as floating representation for each of these indices. So let's take an example here how this will actually look like. So, for example, let's say this 15, and the Keras embedding layer is going to return an array of dense numbers. So this is going to be your dense number or floating number representation. So this is going to be the dimension of 100. Okay, so this is a 100 dimension. Now the max length or the input length is max length, which means 160. So what we're saying is one sample. So this is 100 numbers, another token, 100 numbers, another token, 100 numbers, and likewise 160 of them. So this is one sentence or one movie review, and each of these would be a token, and these tokens are nothing but time step. So that means your LSTM will be unrolled 160 times. So your LSTM will look like something like this. So there would be these cells, so 0, 1, and 159. So this is how the model is going to look like. So as you would notice, this embedding is a random representation. That means you can substitute the other embedding like globe or fasttext or elmo or even the transformer based embedding here. In this example, I'm taking a very vanilla type of embedding layer. So once we define the embedding layer, the next step is to define the number of layers that you want to stack one above the other. So there are three layers that I have chosen in this model. This is again a subject to experimentation, and try and see how many number of layers, LSTM layers, that you should add. The point to note is the final layer that I have here does not have return sequences as true, because this is a classification problem, and the all the other layers will be connected through the time step. So for example, time step 1 of layer 1 will give the output to time step 1 of layer 2, and so on and so forth. So we need to turn on the return sequences equals to true for all the layers but the last one. Finally, attach a classifier at the end with the number of units here. Since this is a binary classification, so number of units is 1. If it is more than 2 classes, ideally, this would be a softmax classification then. Compilation, you can again try different optimization methods, optimizers, and binary cross entropy, because this is two-class classification. Accuracy is a measure here. I'm going to use early stopping and learning rate decay. Again, these are subject to experimentation as to what would be a factor and the patients and so on and so forth. The training time for this data set is around 8 minutes, but I'm not going to run this, but I'll show you the outcome here. At the end of this, in fact, it does early stopping by end of the epoch number 6, and the validation accuracy is pretty good. With this very vanilla setup, you're getting 88% around that. Training accuracy is also very good. So the plotting shows quite good results in terms of accuracy and also the losses. Now, for practical purposes, you are not going to be using the embeddings in this form. So with the proper embeddings used, like Glove and FastX, or transformer based embedding, the results could be even more reassuring. So that's it in this presentation. I'm going to attach the code in the description below. See you in the next video.